Let's take a look at a very short section. You'll see that your homework assignment for this section is one of our shorter ones. I believe only 15 problems total. Now, this section can look intimidating because it has a bunch of formulas in it. We have at least 4 product to sum formulas and another 4 sum to product formulas. But please keep in mind, now in the last section, I said you didn't have to know the formulas in 5.3. But sometimes you might want to know some of them. We don't have to know them on tests. I really emphasize that in section 5.4. There is no need to memorize any of these in this section. These are much less used than anything that we've used up so far up to this point. The formulas in 5.3 far more important. So in this section 5.4, we just need to really concentrate on if you're given a formula, then you can apply it to the problem that you're asked to work with that formula. Okay, so up next, we're just looking at, like I said on the entry page, product to sum formulas and sum to product formulas. Our product to sum formulas, if we have the product of the sine of A, or I should say sine of alpha, sine beta, then that can equal 1/2 times the group cosine of the difference between the angles minus the cosine of the sum between the angles. If I have cosine alpha, cosine beta, that's equal to 1/2 times the cosine of the difference of the angles plus the cosine of the sum of the angles. So notice the only difference in your sine formula and your cosine formula is the sine between the 2 cosine functions within. Other than that, they're identical. Well, what if you have a sine alpha cosine beta? Well, then you can say it's 1/2 the sine, the sum of the angles, plus the sine of the difference in the angles. And then, well, what if that order is reversed and you have the cosine of alpha, sine of beta? You can say, well, then that's 1/2 the sum of the sine of the sum of the angles minus the sine of the difference of the angles. And again, the only distinguishing factor between these last two is the sign in between them inside the bracket. Now, let's look at a couple of examples with these product to sum functions. If I ask you to express the sine of 5x times the sine of 2x as a sum, then you'd say, well, all right, this is going to fit that formula, sine alpha, sine beta, because you have the sine of an angle times the sine of an angle. So here's my base formula from the preceding page. 1/2 the cosine, the difference in the angles, minus the cosine, the sum in the angles. Well, that's very easy to apply to this problem. I'll have 1/2 the cosine of 5x minus 2x, the difference in the angles, minus the cosine, the sum of the angles, 5x plus 2x. And then I can say, well, all right, that's just going to give me 1/2 the cosine of 3x minus the cosine of 7x. Done. That's all there is to it. You don't have to simplify beyond that. You have created a product of trig functions into a sum or difference, in this case, a difference of trig functions. What if you have the product of cosine alpha, or sorry, cosine of 7x times the cosine of x? Well, then you use the formula that I introduced on the opening page. Cosine alpha, cosine beta is equal to 1/2 the cosine, the difference in the angles, plus the cosine of the sum of the angles. So applying that to this formula, I'll have 1/2 the cosine of 7x minus x, the difference in the angles, plus the cosine of the sum of the angles, 7x plus x. So this is just going to simplify to be 1/2 times the group, the cosine of 6x plus the cosine of 8x. Done. Now, what if I want to go in the other direction? And quite honestly, this direction's probably more important than the other. I'm thinking of equation solving. Remember, it's much easier to solve an equation if you can get terms factored set equal to 0. Well, you can't get them factored if you have separate trig functions being added or subtracted. One good way to be able to factor them would be using these formulas. Or if I have the sum of the sine of A plus the sine of B, I can say, well, that's 2 times the sine, the sum of the angles divided by 2, times the cosine of the difference of the angles divided by 2. If I have the sine of alpha minus the sine of beta, that's going to be 2 sine of the difference of the angles divided by 2 times the cosine of the sum of the angles divided by 2. Please notice the only difference if you have sine of alpha plus sine of beta versus sine alpha minus sine beta are the signs and what you do to the alpha minus beta within the formula. This one's subtracted, this one's added, this one's added, this one's subtracted. Other than that, it's the same formula. Well, what if you have cosine alpha plus cosine beta? Well, similar to our sine formula, it's going to be 2 cosine the sum of alpha plus beta over 2 times the cosine of alpha minus beta over 2. So you can just say, well, the sine of alpha plus the sine of beta and the cosine of alpha plus the cosine of beta, it's really the same formula. It's just this is in terms of cosines, where this is in terms of sine and a cosine. Now, what if I have cosine alpha minus cosine beta? And this is not a typo. The cosine alpha plus cosine beta solely in terms of cosine. The cosine alpha minus cosine beta is minus 2 sine the sum of the angles divided by 2 times the sine of the difference of the angles divided by 2. It would get very tedious to try to memorize all of these because they're so similar. It's easy to get them confused with one another. I know I would myself, at least over an extended amount of time. So while you might be able to memorize these for a test, it probably wouldn't be good long-term knowledge material. So I'll go ahead and say, if I ask you to do any problems like this on a test, the formula would be provided on a test. Let's go ahead and look at what those types of problems would entail. So I might ask you to express the sum of the sine of 7x plus the sine of 3x as a product. And you say, well, okay. It's the sine plus another sine. That's the sine alpha plus sine beta formula from the preceding page. And you say, well, okay, that's just telling me to take 2 times the sine of the sum of the angles, 7x plus 3x divided by 2, times the cosine of the difference of the angles, 7x minus 3x divided by 2. So I have 2 sine of 10x over 2, that's 2 sine 5x, and I'll have the cosine of 4x over 2 for the cosine of 2x. Final answer, 2 sine 5x, cosine 2x. And the last example I wanted to look at here with you is, what if I have the sum of 2 cosine functions? So the cosine of 3x plus the cosine of 2x. I just have to make sure to use the correct formula from the formula page, and it's this one right here, where I have 2 times the cosine of the sum of the angles. Well, in this case, it's 3x plus 2x all over 2 times the cosine of the difference of the angles, 3x minus 2x, again over 2. So I'll have 2 times the cosine 5x over 2. It's fine to have the fraction as the angle of the cosine function. You might want to put a parenthesis around that angle. It's not mandatory, but probably would look better. And then, of course, I'll have the cosine of x over 2. Now, hypothetically here, and that is the end of this problem. That's the final answer. Hypothetically, though, what if this had been a case where you would have a negative angle inside of your cosine function? Please remember, the cosine of a negative angle is the same thing as the cosine of a positive angle. So even if that last term had been the cosine of negative x over 2, you just said, well, that's the same thing as the cosine of x over 2. The cosine of negative x is equal to the cosine of x. However, the sine of negative x is the negative sine of x. Some of your homework problems will ask you to simplify knowing your even and odd relationship. Remember, sine is an odd function, so sine of negative x is negative sine of x. The cosine of negative x is an even function. So we can say the cosine of negative x is just the same thing as the cosine of x. Just wanted to mention that because that will arise in maybe 2 or 3 of the homework questions. All right, you should be good to go in this section, but please let me know if you have any questions. And as always, I'll be glad to help.